So I think we're done with this. It's not that we're done, I'm just giving up to be very honest. There's nothing else I can really do to optimize this. So we're done. Hello everyone, today we're going to be optimizing the recurrent neural network that we've been building from scratch. So, it works well. The problem is, even if we're only just training it on 50 words, it runs quite slow. Like, we're only at, 2 frames per second? And this is the fastest we can get it to go. So if it takes this long just to get to about 50, 60 epochs, training it on a million epochs is going to take way too long. Well, before we actually optimize, we're just going to see how long it takes the algorithm to get through certain parts of the code. Afterwards, I'm going to go through this documentation about how to optimize in Lua. And I'm going to go through it. Now, we're using Lua JIT, so it may not translate over, but so let me take this line of code, and what I'll do is I'll actually just paste it everywhere, really. What I'm expecting is that backprop is going to be where there's going to be a lot of opportunities to optimize our network. If we were just implementing this in a game, I'd be fine. The problem is when it comes to training, if I want to actually train competent agents and package them in a game, there's just no way I can do that right now with how slow this runs. So we'll just let that run for maybe like damn, taking forever right now. Close, get out of here. So obviously our training time is taking forever. Our SGD is taking forever. Our backprop function itself actually isn't that bad. We can optimize it though. Let's set a benchmark just so we can have one thing that we can compare everything to. I think our good benchmark would be the create dropout mask function. From what I've seen from this code here, I believe that this is quite efficient already. So now our benchmark is 0.001. First thing we need to work on is backprop. Normal backprop is about 0.01. We want to make that 10% faster, get it down to 0.001. So one thing I want to do now is I actually want to go through and print out how long it takes to do each part of this backprop code. Now let's just see which block takes up the most time. And it looks like block 2 takes up the most time. Okay, second block, let's go. Let's do this. What's taking up so much time in here? A couple of main things really that I see. Number one is use local functions as much as possible. Rather than accessing global variables, I'm just trying to create local variables for each of these functions that we call over and over and over again within this loop. Hopefully that will optimize things just a little bit. Man, if this unlocks, we'll see what happens. I'm not really holding my breath to see whether or not this is going to be like an amazing thing. It's going to make our neural network all of a sudden run so much faster. I think these are going to be like okay-ish changes. Apparently we have a matrix transpose function that we also use. So let's go ahead, let's create a local variable for that. Is this even healthy? There should be a limit how many local variables you can just declare. Which one was this? Clock 2? It's taking about 8 seconds or so. I don't even know if this is a second. It was just 0.008 and we're trying to get it down to 0.001. So let's see if we've moved the needle in any way. Damn! Nope, not really. Taking a look at what we ran before, I think the lowest I've seen is 0.06. And so we've kind of shaved it off very, very little, which doesn't seem like a big deal. But to be very honest, when you're running through this like thousands and thousands of times, it actually is a big deal. So we've gotten it down to 0.005 there, 0.007. I don't see like a major block that's at like 0.01, which is what we saw for the first one. So that's good. What we can see is that things are speeding up, or maybe it's just placebo and I'm just imagining it. Yeah, it might just be placebo to be very honest. No, this is 0.004. That's not bad. This is the first time I've seen a number that low for backprop. That's not bad. That's not bad at all. Our clock 2, which is our backprop, yeah, it's about like 0.004, 0.005, which is not bad. Again, we started with like 0.008. Oh, yeah, when it comes to the layer outputs, when it comes to the hidden layer, when it comes to the dropout masks and like all these weight, can we produce local versions of them and use those local versions in our calculations? We'll see. I mean, we haven't really gone past this 0.004. Oh, damn, it's 0.007. Which when you think about it, 0.07 is pretty much 0.08. So is that all just for nothing? No, please no. I think that for the first one, 0.008 was actually on the low end. The lowest we saw was 0.006. And so the fact that we're able to go down to 0.004, I think is crazy. Again, once that gets simulated thousands and thousands and thousands of times, that small difference is actually quite dramatic. So I'm not really too upset, and I don't really think we've wasted a bunch of time. 0.009. Yeah, no, that's not encouraging though. So I think we're done with this. It's not that we're done. I'm just giving up to be very honest. There's nothing else I can really do to optimize this. So we're done. Let's come down here. Let's get rid of this. And let's just see what our back prop is like now. Pretty much all I could really do. Not really too much to celebrate. So our total back prop time. Did that really even change? I would say maybe yes, because like again, the lowest now is like 0.007. A high value here that we had was 0.014, which is quite high. We've cut it down by half. I think that's crazy actually. Let's pat myself on the back for that. Here I am beating myself up. I pretty much cut it down by half. That's wild. It's absolutely wild. Oh, okay, never mind. We're gonna pretend we didn't see that. Our momentum update, like I don't really think there's anything we really need to do here. Pretty much runs, you know, at the speed we kind of want it to, which is 0.001. It goes over sometimes. Let's see what we can do for momentum update. Let's see if that changed anything. Oh, damn. It's gone down to like instantaneous. Not bad at all. And like the maximum I can see is about half of what we had before. It's not super crazy, but if we can cut a few functions down, and if we can make them run twice as fast, I think that's a major accomplishment, major achievement. The last thing we're going to do today is SGD. Again, let's just do kind of similar to what we've been doing before. And then table insert should not be a thing. So what we should do is loss I is equal to self.loss. Let's see what we have for SGD. So again, we're looking for it to be less than like 0.4, and we've definitely achieved that. Maybe we even cut it down by like half. Okay, not necessarily by half. It's in like the low 30s, high 20s. Not bad at all. So what I've done is I've gone through and I've begun to make some optimizations to the network. One thing that I had to optimize was the backprop function. I had to optimize the hell out of that. So all these local variables are just Lua tricks that I'm using. After doing all these different optimization tricks, what we've done is we've cut down backprop by like half. Is it by half? I think it's by half. Yeah. Anyways, keeping that in to make myself look good. No, just kidding. No, actually keeping it in though, but not to make me look good. Anyways, let's move on. So we've also cut down momentum update by about half. Again, using the same tactics, changing things from dictionaries to arrays. This V variable was a dictionary before. We've turned it into an array. And with all these small little tweaks and tricks, we've cut this down by half. We haven't cut down the stochastic gradient descent optimization function by half, but we've definitely optimized the hell out of that as well. I would say we cut it down by maybe like 25%, which is not bad. Tomorrow we're going to be updating. We're going to be optimizing Nestral's momentum update, and then I'm probably going to be in crazy optimization mode. So whatever the hell else I can optimize, I will probably optimize. But I mean, look, let's be honest. I think bottom line, we're making all these optimizations, but it's not really speeding up our network that much. So yeah, but that's what multi-threading is for. And then the last thing we're going to do is we are going to look at multi-threading. So, damn, I don't think we're going to get through all of that today. Yeah, we're definitely not going to get through all that today. So, whatever. We'll do as much as we can, and then we'll put it off till tomorrow. I'm not gonna redo that intro because I don't even know what I said. Yep, I knew it. I knew it. I think we're gonna spend a few days at least optimizing our code. Oh well, I really hope those that are expert in Lua forgive me for this absolute monstrosity. Damn, this is much faster than what we had. I'm so proud. I'm so happy.